All right, welcome back, 8th graders. We're going to talk about 5.5 example 2. Remember in the last video I showed you how to check, how to test a point to see if it works in an inequality. Showed you how to do that. I hope that was a short little video for you. Today, right now in example 2, we're going to learn how to graph linear inequalities. Okay? So it's very similar to what we've already been doing. It's just with linear inequalities, there's going to be some shading to do. So that's the difference. If you'll write the word shading out here, just remember when we do inequalities, we're going to have to shade one side of the line or the other because that's where all the answers are. So some shading is going to happen. The other thing I need to point out to you, and if you'll just put a big, heavy, dark box around that, this is your key. And I'll write that out here to the side. This is the key for you to determine what kind of line you're going to draw, okay? If you see just a plain old less than or a plain old greater than, you're going to draw a dashed line connecting the points that you've graphed on your graph, okay? If you see an equal to under each of those, then that means we're going to draw a solid line. Now, what does that mean in essence? Well, the dotted line or dashed line indicates that the points on the line itself will not work when you plug them into the inequality. When you test them, they won't work. And so the only way to determine that this is the barrier, but don't count these as part of the answer, is to draw a dashed line. That's the indication that that's true. Now, if you draw a solid line, you're saying this is not only the barrier, but it's also all the points on the line are true and will work in this inequality, okay? So let's start with letter A. Y is less than 3x plus 4. Do you see that it looks like it's in y equals mx plus b form? Do you see that? I hope you do, because it is. The only thing different is it's not an equation, it's an inequality. So what I normally do in this type of situation is I write down some things. I write down, okay, the slope is 3, so that'll be either 3 over 1 or negative 3 over negative 1. And it's going to crisscross at positive 4 on the y-axis. And then I also look at the inequality symbol itself. And I go, hey, that's a less than. So from my key, that means I'm going to draw a dashed line. I can't tell you how many times as a young student your age, where I would get so into what I was doing, I just didn't pay attention. I'd draw a solid line and have to go back and erase. So I slowed myself down, and I'm just trying to tell myself ahead of time, remember, dash line when we actually draw this. Okay, so what I'm going to do is I'm going to draw the coordinate plane a little far down, okay, and I'm actually going to change colors just for effect. I'm going to go ahead and change to red. I drew the coordinate plane in black, but if you want to change colors, please go ahead and do that. That doesn't hurt my feelings at all. That'll just tell me you were paying very close attention to the video and didn't want to mess anything up and you want to emulate me, so that's a good thing. All right, now remember, when we graph out a slope-intercept form, you're going to always start here with the y-intercept. So find positive 4 and mark it. That point is on our line. Now we're going to use our slope to find a couple of other points. So I'm going to do the positive version first. I'm going to go up 3, right 1, okay? And I'm also going to, from back at the y-intercept, I'm going to go down 3, left 1. And there we go. So that's at least 3 points right there. That's plenty of points. Is it leaning the correct way? Because sometimes you can catch a mistake if you just ask yourself that question. I've got a positive slope, it's leaning right. Is it leaning the correct way? Yes, it is. Okay, now, this is where I need to slow down. Don't get gung-ho and draw a solid line all of a sudden through it. Remember, the inequality symbol is less than. So I need to do a dashed line or a dotted line. So be really careful as you do that. I usually start and work my way up just like that. And there we go. and you're making it a dashed line. So if you need looks like mine's got a little hook on the left end there. Sorry about that, it's not as straight as it could be. If you need to use a straight edge or a piece of paper, go right ahead. I was freehanding it. I don't always do a great job freehanding. Okay, so we did a great job. We graphed the line. We knew it was dashed, but we need to figure out which side is the less than side. Which side has all the points that make this inequality true? Okay, so is it the left side? Is that the less than side, or is the right side of the line? Is that where all the answers are? Okay, now this is the strategy that I use, and it can be confusing. I don't mean to be confusing. I'm going to erase my question marks now, okay? And because it's not going to be a question mark anymore, we're going to figure this out. Okay, to figure out the shading, I usually pick the easiest point to plug into. As long as my line does not go through this point, I use 0, 0. I use 0, 0 as a tester. Okay, I use it as a test point. If it works, then the side of the line that 0, 0 is on is the side I should shade. If it doesn't work, then that's not the side I shade. I shade the opposite side of the line. Okay, so let me show you when I plug 0, 0 in. That's a pretty normal point for me to plug in. I plug in 0, 0. I'm saying y is 0, x is 0, and then I just plug in and see what happens. So I know 3 times 0 is 0, and 0 plus 4 is 4. So this is my bottom line statement. Is 0 less than 4? Yes, it is. So what that tells me is the side that, here's 0, 0 right here. The side that 0, 0 is on, see how it's on the right side of my red dashed line? That means the entire side, every point on this side of the red line is going to work in that inequality, every point. And so I use long, skinny lines to do that. You can do squiggles, just indicate it some way, the shading, so that I know what side of the line you're shading. So with inequalities, what you have to do, you got to slow down. You graph your line the same way, but you either dash the line or keep it solid, and then you have to shade one side or the other of the line. Okay? That's the difference, shading and whether it's dashed or solid line. Okay, let's take a deep breath. Let's switch back colors again. There we go, and then just erase just a little bit. Let me make my eraser a bit bigger. There we go. I don't need quite that much shading. So, okay, I'm going to leave that up so you can see it. All right, let's go to letter B. Now that's in standard form. If you just really feel compelled that you want to turn standard form into a slope intercept form, knock yourself out. Okay, if that's how you like to graph them at a slope intercept form, you can rearrange it and graph it that way. You have my blessing. Go for it. Well, standard form can yield you good information as well. Remember that good old cover-up method where we cover up 3x and we're left with 2y is equal to 6, and where we cover up 2y and we're left with 3x is equal to 6. We can actually find the intercepts using the cover-up method. And so the y-intercept is going to end up being 3, and the x-intercept is going to end up being 2. That's really all the information I need. I just need 2 points. I found them. I don't really need to go and do all this extra work of rearranging into slope-intercept form when I don't have to. So I'm just trying to show you a little bit of a shortcut how to handle standard form situations. Now let's look at that inequality symbol. That's a greater than or equal to. So that tells me solid line, okay? Solid line. Let's get this thing graphed. Let's see what's going on here. All right, there we go. Okay, I did not do a good job on that y-axis, so I'm going to redraw. I don't know why I'm having a hard time today. Okay, So let's find positive 3 on the y. There it is. Positive 2 on the x. Perfect. I need to draw a solid line because there's an equal to sign there. All right, got it. So now what I need to do is I need to discern which side should I shade. Should I shade the side to the left of my line, or should I shade it to the right of it? I got to figure out where the greater than side is. So I always like to test 0, 0. That's just my go-to. As long as my line does not pass through 0, 0, I can use it as a tester point. You can use any point that's not on your line to test. You're not locked in. You don't have to use 0, 0. I'm not suggesting that. I just think 0 is easier to plug in. That's why I like it. Because look what happens. I plug in 0 for x. I plug in 0 for y. And I got to see if that's greater than or equal to 6. So 3 times 0 is 0. 2 times 0 is 0. Is 0 bigger than or equal to 6? Well, no. 0 is not bigger than or equal to 6. So I'm not going to shade the left side of the line. I'm going to shade the right side. All these points over here are going to be the points I can plug in, and they will always work. They will make the inequality true. Okay, so let me recap. When we do linear inequalities, when you graph, you're looking for a couple of extra things you're doing. You're still going to try and find slope and intercept if it's in slope and intercept form, and graph the line using those, or the cover-up method if it's in standard form. So that's not different. What is different is what kind of line are you going to draw. If you see an equal to sign, it's a solid line. If you don't, it's a dashed line. Okay? And then, of course, don't forget to shade. Figure out which side to shade. Pick any point that's not on your line. Plug it in. See if it works. If it works, shade that side. If it doesn't work, shade the other side that that point is not on. Okay? So if you have any questions, please bring those to class tomorrow.